Hi, in this video, I'm going to discuss how to apply the pooled variance t-test for two population means. And this is done when the population standard deviations or variances are unknown. So we don't have any information about the population standard deviation. And the added condition is that these variances or standard deviations are assumed to be equal. Another case of this t-test for two population means will involve variances or standard deviations that are assumed to be unequal. But in this video, we'll focus on the variances that are assumed equal. So there are additional considerations. Number one is that the samples should be independent, so they're not related. The sample sizes are small, that is n is less than 30, and we have to consider that samples are taken from normal populations. If these conditions are met, then we use the following t-test statistic, and this is the formula that we will be using to find the calculated t. Note that we're using the t because the variances are unknown, and at the same time, the sample sizes are less than 30. So take note of the values that you need to consider. x1 bar is the sample mean of the first group. x2 bar is the sample mean of the second group. Mu d is basically the difference between the two actual means, the true population means. So this is mu1 minus mu2. Now, in most cases, the mu d is assumed to be 0 when, or the mu d is 0 when the two means are the same. That is when we set the null hypothesis to be mu1 is equal to mu2. So their difference, if they're the same, if they're equal, their difference is 0. On the denominator, we have the sp squared. As you can see here, sp squared is our pooled variance. So pooled variance because we're using the same variances for the two groups. That is why in our intro, we said that we are considering two population means with unknown variances or standard deviation, but they are assumed to be the same or equal. So that number, the value that we need for that is calculated by this formula. N1 minus 1 means the sample size of the first group minus 1. S1 squared is the variance of the first group. And then you replicate that here. You use the sample size n2 minus 1 and the corresponding sample variance s2 squared over the sum of n1 and n2, the sample size 1 plus sample size 2 minus 2. And later on, we'll be using this n1 plus n2 minus 2 as our degrees of freedom when we look for the exact value of t. To guide us in our hypothesis test, we use the following. So HO is our null hypothesis. By default, mu1 minus mu2 is equal to mu d. And the corresponding alternative will be, if it's equal, then not equal. Sometimes it's greater, sometimes it's less than the difference. Now, do not be confused with this mu d, because when we have the mu d, the mean difference, mu d is the mean difference of the two means. If the mu d is 0, then that means mu1, if you transpose mu2 on the other side, then mu1 is equal to mu2. So if there is no difference indicated, that means we can set mu1 to be equal to mu2. And with that, the corresponding alternative hypothesis will be either mu1 is not equal, the opposite of equal, or maybe you want to test whether mu1 is greater than mu2, or you might be testing mu1 is less than mu2. And the decision rule, so this is how you will decide whether to reject or fail to reject the null hypothesis. For not equal to, take note that you will be creating a two-tailed diagram, and the critical values will be your t of alpha over 2 negative and your t of alpha over 2 positive. So the first statement here, if t is less than negative t of alpha over 2, this t is the one that you have calculated with the formula. If that t will fall in this region, meaning it's one of these numbers, then the conclusion is to reject. Or another case would be when t is greater than t of alpha over 2. That is, a number is in this region, so that means we also reject. However, if the value will be in between these two numbers, these two critical numbers, then we say we fail to reject. For greater than, so that will give us a diagram that has a right tail. So same idea is used. Your t of alpha is located here. If the calculated t will fall in the area of rejection, in the rejection region, then our conclusion is to reject. But if it will fall in the opposite region, then we say we fail to reject. For the t less than t of alpha, it's the same idea, but this time the region is on the left. Then you have this critical number, your t of alpha, which is technically positive or negative. So just to avoid confusion, this is negative of t alpha, so negative t alpha. So if the number t will fall, so if this t, calculated t, will be in this region, then we say we reject. Okay? So those are the things that you need to know before you can perform the steps for the hypothesis testing. So again, I explain what is the t-test statistic to be used. There is also a formula for the pool variance, which I also explain the different components, and in which the denominator will be used as a degree of freedom, and then your guide in making your conclusion. Okay, your null hypothesis, your alternative hypothesis, and the decision rule. So let's look at one example. Suppose you wanted to test whether the average scores of the male and female students in the mathematics examination are equal at 5% level of significance. So you obtain data by taking a random sample of scores of 10 male students and 8 female students who took the examination. You found that the male students have the following scores: 82, 84, 79, 86, 90, 92, 85, 83, 91, and 86. While the female, their scores are 78, 96, 87, 88, 90, 91, 82, and 84. Now, assuming that in this hypothesis testing that you are going to perform is that the scores of the male and female students are normally distributed and that the variances are assumed to be equal, what will be the steps, or show the steps of this hypothesis test? Okay, so we already know that these two groups are independent. The male students and the female students, their groups are independent, so condition is satisfied. The sample sizes are small because for the male students we only have 10 and for the female students we only have 8. So both sizes are less than 30. And we know that we have to perform the pooled variance t-test because according to this problem, we have to assume that the variances are equal. So this sets the type of test that we have to perform. The variances are assumed to be equal. It's a pooled variance t-test, so we have to perform pooled variance t-test because of the conditions. Okay, so let's start with our hypothesis test. So first thing to do is to set the symbols for our parameters. So let's say let mu1 be the true average score of the male students in this examination, while the mu2, so mu1 and mu2 is or be the true. So take note of the word true because it means this is the actual average score if you ask all the students who took the exam. If you ask all the male students who took the exam, and mu2 will be the actual average score of all the female students who took the exam. But we don't know what the numbers are. Okay, that's why we took a random sample of 10 students, male students, and 8 female students. So mu2 be the true average score of the female students. So once we have set mu1 and mu2, we can now state our null and alternative hypothesis. Note from the statement that what we are trying to show here, what we are trying to find out is that whether the scores of the male and female students in the examination are equal. So that means our null hypothesis will be mu1 is equal to mu2. Also, in the problem, it was never stated whether we want to test if one group is performing better than the other. So there is no way to set mu1 to be greater than mu2 or mu1 to be less than mu2. But all we can do is that we have to set, or we set h1 as not equal to mu2. Okay, so that's how you determine what is the alternative hypothesis. Then we go to number 2 step. In number 2, we identify some information, and the most important information is the level of significance. The alpha is set to 5%, which means it's 0.05. Also in number 2, we can take note of some information, or we need to compute. X1, this is the sample mean of the male students. X2 bar is the sample mean for the female students. In addition, we also have to compute for S1, the standard deviation for the scores of the male students, and S2 is the sample's standard deviation for the female students' scores. So these numbers, unlike the other problems in the hypothesis test, these numbers are not yet given because you have to compute them from the given data. Okay? So I'll pause the video for a while. I'll compute for the values for the x1 bar and x2 bar together with their respective standard deviations. From my computations, I have found the sample mean for the male students to be 85.8. The sample mean for the female is 87. The sample standard deviation S1 for the male is 4.1580, which came from 4.15799. and the sample standard deviation for the female is 5.6315. So if we remember with the sample standard deviations, we know that the female student scores have a bigger variance, so they are more spread compared to the scores of the male students. Now, in addition to this information, we could also just note our sample size 1 to be 10. This is for the male, and sample size 2, we have 8 for the female. So once we have this information, we go to step number 3, and that is we compute the t-test is statistic. T-test is statistic. And according to our formula, the t is the difference between the two means minus the mean difference over the square root of sp squared 1 over n1 plus 1 over n2. In addition, we have to compute for sp squared, and that is n1 minus 1 times s1 squared plus n2 minus 1 s2 squared all over n1 plus n2 minus 2. Okay, so I think for pooled variance, it is better to compute sp squared first before we calculate the t. So sp squared is, we have 10 minus 1 times s1 squared. S1 is 4.1580. 4.1580 squared. Note that I use 4 decimal places so that when we round it off in the last step, it will not be that different. Okay, so make sure to work with 4 decimal places within the solution. Then plus n2 is 8 minus 1. Sample standard deviation for female is 5.6315. 5.6315, you have to square. This is all over n1 plus n2 minus 2. Oh, the values are 10 plus 8 minus 2. So this is now equal to, so let's compute. So my computation shows 23.5998, again up to 4 decimal places. So this value is the one that you have to put inside. So this number should go here. Okay, so let's compute for the t. So the t now is equal to x1 bar minus x2 bar. So let's get the x1 bar, 85.8 and 87. So 85.8 minus 87 minus the difference. Now, according to our null hypothesis, we have mu1 is equal to mu2, which means mu1 minus mu2 is equal to 0. And mu1 minus mu2 is basically our mu d. So mu d is 0 over the square root. That's where we put our pooled variance, 23.5998. 23.5998 times 1 over n1 10 plus 1 over n2 8. Then let's compute this using our calculator. So what I got is a negative 0.5208. It came from 0.520757. So rounded off to 4 decimal places, we have negative 0.5208. Okay, so we go now to step number 4. Step number 4, we create the diagram This is a two-tailed because what we want, so according to our null hypothesis, this is what sets the diagram, or the alternative hypothesis. Mu1 is not equal to mu2 means we have two-tailed or two tails. So number 4, so let's do that here. Left tail and then right tail, and we need these critical numbers which are based on our alpha. Our alpha is 0.05, but since we have two tails, we have to divide it into 2, so 0.025. We're doing t-test, so we need to identify what is our t of 0.025. So we refer to our t table, and we use the degrees of freedom n1 plus n2 minus 2, which is, in our case, it's 10 plus 8 minus 2 equals 16. So this is the number that we have to locate from the t table. So to identify the t, so let's look at the t table. We need the t of 0.025, so this is what we need. Now don't be confused with this alpha. This alpha could be alpha or alpha over 2, but when you refer to the t table, just refer to the subscript. Okay? When it says t of 0.025, it means that's exactly what we need. Okay? That's why we divided the alpha into 2. The 0.05 became 0.025, so use a t of 0.025. Degrees of freedom is 16, so we go to the 16. This is the 16. So under the t of 0.025, then the 16, so this is the number that we need. So we plot that in our diagram. So two tails, of course the t table will only list the positive numbers. So the negative goes to the left side, negative 2.1199. On the right side, we have positive 2.1199. So from there, we go back to step number 3 and get that number and place it in the diagram. So if 0 is located as the center, or the 0 is the center, then the negative 0.5208 should be on the left of 0, but should be on the right of this critical value. So as we can see, the number did not fall under the critical region. So that will lead us to our conclusion in number 5, that since it's not in the rejection region, we failed to reject HO, that is, there is no sufficient evidence supporting that mu1 is not equal to mu2. This is our H1, no evidence supporting H1. So we will stick with, therefore, mu1, so therefore mu1 is equal to mu2 as set as the null hypothesis. So fail to reject, there is no sufficient evidence supporting the alternative hypothesis, so we stick with mu1 is equal to mu2. So that means if mu1 is equal to mu2, then the male students' average score is equal to the female average score. Or at least we say that there is no significant difference between the two average scores of the two groups. Okay, so that's how you perform the hypothesis test for two population means with, so here's our starting point, two population means, population standard deviation and variances are unknown but assumed to be equal. Now, to easily identify whether the problem is about two population means with variances unknown but assumed to be equal, it will also help if you look at the format of the problem, usually by just looking at the data that you have. You have sample sizes less than 30, and there is also an indication that the variances are assumed to be equal. So immediately, this will fall under the pooled variance t-test. So from there, you perform the steps. Don't forget to set some parameters, mu1, mu2. State your null hypothesis and the alternative hypothesis. Get some data. Your significance level should be there. Any information that you have or you need to compute, you list in the number 2. Number 3 is where you compute for the values. So since you know that this is under the pooled variance, then you have to use the t-test statistic formula for the pooled variance. Make the corresponding diagram. Use the significance level to identify the critical values. Locate the t-value using the alpha with the respective degrees of freedom n1 plus n2 minus 2, and then you place the computed t in the diagram, then decide whether to reject or fail to reject the null hypothesis. And in this problem, we have found that we cannot reject the null hypothesis because there is no sufficient evidence supporting H1, which is mu1 not equal to mu2. Okay, so I hope I was able to make you understand how to perform hypothesis testing when the variances are unknown, the samples are independent, you're working with two populations, and the variances are assumed to be equal. Okay, that's it.